Hello, everyone. Oh, this is very loud. It's good to be here in Belgrade. My name is Amir Golan, and I'm a product manager for Amazon Web Services. And I'm here today to talk to you about continuous delivery and what it means for us in Amazon and how we use it even internally. I'm here also to talk to you about some of our newest development tools and how we make our own life easier and also yours. So, what's the main reason we're all here today? One of those reasons is the fact that the industry is changing. This industry continues to change by becoming faster and faster. Software itself moves faster today as opposed to what it used to be, and I'll show that in just a little bit. Today, every single startup that starts in a garage can disrupt a giant, topple it off its feet. And getting started and bringing your software, whatever you build, to your customers, your end customers, is faster than ever. If we take a look back on how things used to be, back in the day, when you purchased software, you went to your local or closest Mr. Robot shop, where you got your software on a magnetic disk, magnetic drive, and you went home after you bought it, placed it in a drive, and you had your software. That was the software delivery model. Today, it's a little different. In today's world, we consume software quite differently through our tablets, our smartphones, even our cars. That's happening. And if you have Alexa, you can just ask for new software and you get it. Again, this entire model has changed throughout the years. So, what are the tools, or some of the tools we're going to talk about today that will help you move faster, work faster, be more efficient? Those tools are the ones that are going to be a part of your software release process. These are tools that will help you test your code from the time it's being created or pushed into your version control up until the fact or the time that it gets to production, gets to your customers, and will help you find all the potential defects and failures in the process. We'll also talk about some of the tools, the deployment tools that help you reach that stage. But before we get into this, I'd like to start with the donut analogy. I'm not local, so you'll have to help me out. Do you have Dunkin' Donuts around here? Is this a thing? What brand of donuts do you have so I can relate? Grandma's. That's a thing. Fantastic. So you have Grandma's Donuts. I'm sure when you buy Grandma's Donuts, or at least I hope, you get consistent donuts. You always get the same donut size. It's not too small, and it's not too big. It's a very expected size of a donut. And that consistency is something we should all strive to when you're doing software development. We'd like to be able to predict what we're getting in the end of the day, which, in fact, is a perfect donut, or close to perfect. So to build a perfect donut, what we'll need to do can be separated into 4 main stages, which is source, build, test, and production. And we're going to talk about a little about the tools that live in each of these spaces. Starting with the source. This is where you check in your code, right? We all have GitHub accounts. This is also the process probably to get some peer review, get some feedback from your peers, from your team leader, from your software lead, from other colleagues on the code, either the quality or the structure and how you work, that it actually adheres to how the team works. After that, we have build, right, which is where we recompile our code, perhaps do some unit testing, run style checkers, run code metrics. In today's world, if you're using containers, even building a Docker image is also considered a part of the build process, turning a Docker file into a Docker image. Then we have our test. After we finish the build process, we actually have a finite artifact. We have a binary we can start testing on. We place that binary with other systems to see how it interacts with them in integration tests. We do load testing, UI testing, and again, security tests, everything we need to increase the probability that our software, our artifacts, our binaries will be successful when they hit production. And of course, after we've validated our artifacts, we validate our code, we can push it to production. So there are three types of release processes that are commonly known in the industry. We've got continuous integration, continuous delivery, and continuous deployment. Each one is very different, but including the step behind it. So if we look at continuous integration, it deals from the time I push my code into my version control up until the time I have a build artifact. Now, this is how usually the industry defines it, or at least that's how our customers tell us they define it. But every company considers continuous integration a little differently. So again, from the time I have my code, I push it until the time I have a build artifact, and potentially even test it, depending on how I run things in my company. This brings us to continuous delivery, which of course includes continuous integration, but builds on top of it. Continuous delivery also includes all the tests, the integration test, of course the code tests, everything I need to do again to verify or to increase the chances that my artifact, my code, will run in production. But up until the point where I don't deploy to production yet, I wait for the switch. I wait for a maintenance window, an internal process, potentially even a QA engineer, someone to come and verify one last time and do it in a way that it doesn't interrupt our customer. Which brings us to continuous deployment, which actually takes the human element completely out of the equation. Developer writes the code, pushes it forward, decides this is what I want built, and the entire process up until the point the deliverable, the artifact, the binary reaches production is without any human intervention. But today, we're going to focus on one of those, which is the most popular, which is continuous delivery. Again, from the time I push my code to the time I have a production-ready artifact, or my code is production-ready, that is continuous delivery. And what it lets us do is it lets us automate the software release process. And by doing automation, we are improving our own productivity because we don't have to focus so much on maintaining this entire process, this manual, or used to be manual, process of getting our code to production. And because of that, we can focus on what we want to do best, which is write code. Of course, this also lets us, this automation has bug fixes or potential bug fixes baked into the process. If the pipeline or the release process breaks in the middle, we can very quickly identify where it broke and fix that specific problem. We can identify and pinpoint problems significantly faster than we could have before using this structure. And of course, if you combine all these benefits together, you get much higher results. You can release your software and get it to your end customers at much faster intervals. Now I'd like to give you, let's say, a window into how we do things at Amazon, or how they used to be and how we do them today, how we reach those conclusions. Well, initially, just like many companies back then, and even some today, we used to have a monolithic application approach. We had one big application or a very small subset of services that was maintained by a significant amount of teams, everyone working on the same code base. This created some problems. We had ownership problems. If something breaks, who owns a fix? We had dependency issues. Teams were depending on other teams, and teams would regularly affect the work of other teams. This has had an array of problems, which you're probably familiar with by now, given all the changes our industry has been through for the past years. This made us do a shift in 2009 to a microservices approach plus a two-pizza team approach. Anyone familiar with a two-pizza team approach? Okay, I see two hands. Very solid. So, 3 hands. So the two-pizza team concept is you take your problem or a wide array of problems and you break it down into small pieces or small services, microservices, and you give those to teams that can consume no more than 2 pizzas. So depending on how hungry the engineers are, we're talking about teams of 4 to 6 people that can consume up to 2 pizzas. So break down every problem into these small teams, and every team owns a service, a microservice, or several ones. Again, adhering to this 2-pizza rule. And using this, we of course got significantly better ownership. When something breaks, we know exactly where to pinpoint the problem and which team is taking ownership of that problem. We of course also don't have teams taking big dependencies on other teams and risking breaking works in between while all working on the same code base. When we made this change, things went much better. But we still felt there was room to improve because we were feeling we're still kind of slow. This is why in 2009, we also ran a study where we found internal inefficiencies in how we work. And those inefficiencies were because we had to wait a lot. So we were just in the process of continuously waiting for things to happen. Developer writes us code, and then he opens a ticket to the team that builds that code, that gives them an artifact at the end of the day. Opening a ticket took time. Responding to the ticket also took time. After it's built, you need to start testing your artifact. So you open multiple tickets to multiple teams, depending what tests you want to be done. This also takes time, and you have to wait for them to respond. And every time you move in between stages, you also wait. So it's just waiting a lot. So while writing our code or doing a code or writing a version I'd like to test in production or run to production or in a staging environment took minutes, the wait till the code actually got to production or to another staging environment was very long. It was so long that it was taking up to weeks on end. So from the time we build our code, we have a code we'd like to run on production or run on staging environments, till the time we actually did that, that process might have taken weeks, all because of the wait. Again, because of something we like to call the human element. Again, someone needs to respond, someone needs to act, someone needs to close a ticket, open a ticket. This entire process was very, very inefficient. But back in the day, it was unavoidable until we decided or understood we can actually reduce that time by taking out all the wait. So we took those weeks, of course, turned them into hours, and we built a set of released process tooling that will help us run through this process. That tool, if you can see by this picture, is called internally, or codename internally, pipelines. And it lets us automate the transitions between each and every of those stages, right? Moving in between those stages in an automated fashion, from the time we check in our code till the time we get it to production. The benefits, of course, are very, very clear. It's significantly faster. We removed all the wait. It's safer because we removed all this manual process of someone having to check and respond to your ticket. And therefore, because it's automated now, there's less room for mistake. If there is a mistake, it's a mistake in the automation, it's a mistake in the script, it's a mistake in the transition, but we can pinpoint that significantly faster. And now, again, the entire process became much safer and simple. Because we did this, we've been able to replicate this on a per-service basis. So we created a standardization template by which we work at. And again, standardization usually brings speed. And of course, our internal tool also lets you completely visualize your entire pipeline. You can see the state of your code as it gets pushed until the time it reaches production, passing through 5, 6 stages, and you can see it all in a visualized fashion. You can see your code actually transition in between every single stage. So this approach continued to work very well. If we look back at 2014, we had thousands of teams building microservices and maintaining microservices every day. And they were practicing, and you're doing this by practicing continuous delivery. We have an uncountable amount of staging environments, again, all through our various pipelines across our various teams. And in 2014, we made 50 million deploys, which is an interesting amount. Today, it's actually a lot bigger, but I don't have the exact numbers. So this, of course, continued to work very well and does work very well up until the point that also in 2014, like we do every year, we have something called an internal survey, internal tech survey, where we check what sort of tools are the most popular among our developers. And what we found was we can statistically correlate happy developers with this internal tool called pipelines. So we found that continuous delivery actually equals happier engineers, happier developers, which was a significant revelation to us that made us build this. Anyone familiar with this tool? Okay, then it's good I'm here. So we took all the knowledge, all the things that we learned internally, and externalized it to a public service called CodePipeline. So this new service lets you practice continuous delivery in a very automated and simple way. So automated and so simple, you can get started with your own pipeline in just a few minutes. Under 10 minutes, and you can have your first pipeline and start hooking it up to your existing systems. It lets you model the entire process, again, from the time your code is pushed up until the time it runs in production. And of course, it does this in a visual way, just like our internal tool. And runs through the entire process from building and testing your code on every single change. Whenever you see you need an artifact that you want running on production. Unlike our internal tooling, this also has third-party integrations, the tools that you're probably already using today. So what does this really give you? Well, it gives you speed, a lot of speed. It also gives you an ability to maintain your original investment in your current tooling. You don't have to change anything. You can keep your existing tooling and just plug this in and take some of the load off your existing process and try to automate even more using this framework. Of course, when you practice continuous delivery, as I mentioned before, you get better quality, significantly better quality. Because this process of automating everything has a significant amount of checks and tests in between that forces you to look at quality and making sure that you're actually maintaining that quality throughout the development process. And as I mentioned before, you get speed, and it's very, very easy to get started. So easy that I can create something like this in less than 3 minutes, assuming I have a build server. So this is what it looks like if you try it out in our console. In this example, I took a simple application, named it very originally so, my application. It's a Java application, and my code is sitting on GitHub. I have a Jenkins server, an EC2 instance running Jenkins, and I have an Elastic Beanstalk environment. This entire thing is what we call a pipeline. In between those, you see source, build, and deploy. These are stages. And inside those stages, we have what we call actions. It's fairly straightforward. In between those, when you move between those stages, we got transitions. And you can do very interesting things with it. It's very, very flexible. You can add a custom action, which in this case is notify developers while a build is in process. So while you got, one sec. So you got 2 actions happen in parallel. You can also add a sequential action. Again, while I'm doing my build, once this is complete internally, after that I use run scope to test my APIs of my new application or my newly built application and artifact. This is probably a good time to inject some of your tests, but you can of course add as many of those stages as you'd like, because this pipeline here is completely customizable. Now I'm going to show you an example again of a Java application. Code is in GitHub. We have CodePipeline. Get my latest changes. Gets my code. It places that code in an S3 bucket. Then there is transition to the build stage where we have an EC2 instance running Jenkins. That Jenkins server pulls for a job, and it gets one once the transition is happening. After the transition is complete, acknowledges the job to CodePipeline, and then gets the artifact, gets the code that needs to be built. It builds the code and stores it in a different bucket called our build artifact bucket. Again, which is also, as I mentioned before, probably a good time to inject some of your tests. Your unit testing, whatever tests, maybe lint testing, whatever tests you see necessary as a part of your software development process, you can have either Jenkins trigger it or you can have CodePipeline trigger it. And the choice is up to you, again, depending on your existing processes. After this is complete, Jenkins reports success to CodePipeline, which continues on to the next transition. In this phase, it takes a look at the Elastic Beanstalk environment and lets Elastic Beanstalk know that it's ready to deploy the environment. It does so by first taking the artifact and instructing Elastic Beanstalk to deploy that artifact to a specific environment, of course. Again, this entire process is something that you can do in very little time. It's very, very fast, and it integrates with your existing toolings. To name a few, you probably recognize some of these. And just to mention, this list is a few months old, so it grew a little bigger since then. So we are talking about, as source control, we support internal tools, which is, of course, S3 and CodeCommit, but we also support GitHub for now. We support for build Jenkins, of course, CloudBees, Solano Labs, and of course, the list goes on and on. We have a very big amount of third-party providers that we work with to make this pipeline match your existing pipeline or integrate with your existing tooling. Some of our internal tools that we use, again, as a source, as I mentioned, we support S3 and we support CodeCommit, which are version control service. And as an invocation logic, we have Lambda. Anyone here familiar with Lambda? Okay. So Lambda is a very, very cool service. You just give us your code, and we run it in a serverless environment. You don't need a server. You don't need an instance. You don't need anything. You just give us your code in one of our supported runtimes, and we run that code for you to do any task you'd like. And this could be, as you've seen before in the example, this could be sending an email. This could be put a log entry. This could be anything. You customize the invocation logic. You can have it call another service. You can define basically any custom logic within Lambda. And I'll give some examples later. And as you've seen in the examples where CodePipeline instructed Elastic Beanstalk to take the new artifact and deploy it to the environment, here we're doing the same with other services. We also support CodeDeploy, which I'll talk about in just a little bit. And of course, AWS OpsWorks that uses configuration management, which you can use to configure your environment using chef recipes. So now I'm going to dive a little deeper into what is the exact process when you build, or why you should build, or when you should build, and of course, how you should test your code. So pretty straightforward stuff to anyone that's been doing software development for a while now. So what is actually building your code? Well, it's referring to specifically languages that require a compiled binary, a binary file, an artifact at the end of the day. And this refers to .NET languages, JVM-based languages, Go, Swift, Objective-C, anything that basically, any sort of code that requires a binary. So as I mentioned before, we also today refer as the transition between a Docker file to a Docker image as also, of course, as building this process. We have languages that do not require a build, which are PHP, Ruby, Python, Node.js, which you can just take your code and run it. No building is required. How would we test our code? Now, this is, as it says in the slide deck, this is an R form. You don't want to put too many tests to burden your team and slow them down, but you want to have a sufficient amount of tests to make sure your code is actually, to make sure the quality is something that you're willing that your customers will eventually use. You want your customers to be happy. And when customers encounter a bad experience, they usually tend to stop using certain products. So quality is very, very important. That's why you need to have a right mix of tests that make sure in the end of the day you get higher quality. So what would you need tests for? Of course, as I mentioned, you want to confirm that whatever you're testing for, your business logic is actually working. Your application is behaving the way it should be, that you're giving a certain value and it returns the proper value given the business logic. You want to test for syntax errors. You want to test for standardization. And I'm not only talking about the difference between spaces and tabs. You want, of course, as I mentioned, to reduce logic errors. You want the business logic to be sound. And last but very not least is security. You want to make sure your code is secure. It's just something customers take very seriously, especially when it involves sensitive data. So how would you start your testing? What would you test for first? Usually you start with some sort of a syntax linter. Again, something to check your code actually compiles. Missing brackets, commas, and whatever needs to be done in the process to make sure your code is actually solid and would basically pass a compilation and a build process. You will later start with a variety of unit testing to test your basic code functions. And of course, move on to different deeper tests to test the business logic. Again, we need to make sure that our application's business logic is very, very sound. Of course, we'll also test for user experience. And we'll also test for UI, right? We want to make sure that when two components, for example, or four components talk, when one of them is in a process of change, the other keeps close tabs and pulls correctly and presents the proper status of that other component. We need to make sure that our components can talk with each other and are updated on the status of other components. How would you focus your tests, or where would you put the effort in actually building your tests? Well, most experts place it like this, but this is a very debatable issue on how or where you should place your effort. We normally see 70% go on user testing, 20% on service and application logic, and the last 10% for UI. This, of course, also includes UX, and this is a very important time to mention that you should really work with your designers to make sure that the customer experience, the user experience, is actually what they envisioned. This is something that's normally being let go, and it's very important. Customers are very sensitive to the user experience, and it's very important to maintain it. By doing extensive UI and UX testings with your designers, user groups, test groups, whatever you need to make sure the flow of usage is proper. So how do we get our code catapulted into production? How do we get our code deployed? It doesn't have to be, of course, to production. It could be to any of our stages. So surprising enough, we also have a service for that. Anyone familiar with CodeDeploy? No hands. So we also have a service for deploying code. It's called AWS CodeDeploy. It's also a process where we've externalized an internal service. And it handles all the complexity of doing deployment for you using various very, very intricate mechanisms, which I'll talk about in just a little bit. What it also lets you do, it lets you avoid downtime by having built-in hooks on what to do before you deploy your applications and after you deploy your application. It's also very interesting because it runs both on EC2 and on premises. That means any server, even your own desktop, this could run on. And just like CodePipeline, also integrates with a variety of third-party tools. When you actually get started with this, this is what you use, the application spec, a YAML file, to define how your application is actually going to be deployed on production or any staging environment. In the first part, you define where you want to place your artifacts and where you want to place your configuration files. You can define, of course, multiple of these in the first section. Then you set a specific set of permissions on the artifacts themselves, on the folders, and whatever you need to. And this is the last part, is when the fun starts, where you can build in your own hooks to your own custom scripts, or some of ours, to do things like deregister an instance from Elastic Load Balancer, because it can no longer serve traffic at this time, because it's being updated. And then install a new set of dependencies, run those dependencies. Again, whatever processes you need to do to make sure your application doesn't incur any downtime or a reduced amount of downtime. You can plug into those hooks whatever scripts you want, and we have a wide variety of those scripts. Another thing that is very interesting about CodeDeploy is something that people neglect at times, your deployment strategy. When you deploy your code, there's a specific deployment strategy that you need to consider. Anyone familiar with a one-box deployment strategy? Okay, so a one-box deployment strategy means I'm first deploying my artifact to a single instance, to a single machine, to see if it's running. And only if this reports success, move on to the next one. Another deployment strategy is do half of the time. Let's say I have a set of instances running from US East 1 and another set of instances running on the west side. So I deploy it on a region basis or based on a number of instances. Again, I define a deployment strategy, and CodeDeploy has several built-in ones that you can choose. And of course, you can progress in between those. Once you feel confident enough to deploy your artifact, your new artifact on the rest of the instances, CodePipeline will do it, CodeDeploy, will do it for you. On the other end, we also have something called deployment groups, right? Sometimes you want to make sure that certain artifacts make it into production, while others make it into some staging environment. So we can define this by placing tags or another identifier on our set of instances and let CodeDeploy know where it needs to place certain artifacts based on a deployment group, once we define it, of course. And of course, the last piece is launching to production, making sure our artifacts, which have been tested, validated, reach into production. But we don't deploy them just yet. There are certain things we need to take into consideration before we place a new piece of software that is placed in front of our customers. Before we launch it to production, we need to take into consideration the impact on our customers. What would this new artifact, what would this new code do to the customer experience? We need to take a good look at our infrastructure and its configuration. How is this new code going to impact our infrastructure? Does it require more resource? Does it require me to change dependencies on the instances? And of course, if you combine both of these, you get the impact of the business. Because your new artifacts do have an impact on your business. And of course, we also have something called custom actions, going back to code pipelines. Custom actions is your ability to build in hooks into your pipeline to do any action you like, anything and everything. Either send you an email, update another application, update a Datadog dashboard, whatever. Test. Lost it for a second. Whatever you'd like to do, you can define it using those custom actions. And I'll show you how this works in this sample pipeline. Again, I'm adding to the stage that I had before. Just before I deploy my new artifact, I added a custom action. Now, this custom action has on the other side an EC2 instance running a custom piece of code I wrote to do a specific operation. It could be a bash script, it could be anything in any language. Just like before, as we've seen with the Jenkins server, it pulls for a job. It gets one. Once we are in the proper stage of the deploy stage, it acknowledges the job. It performs any operations, any predefined operation, running any predefined script or piece of code that I define on that EC2 instance. And once it's complete, it puts success. You can achieve the same results by not using an EC2 instance. And again, coming back to Lambda as an invocation logic. You can inject Lambda into your process just before you deploy your application to run any specific action or custom action. By simply invoking that Lambda function, I can have it run again my code in a serverless environment. Give it my PHP code and have it run it. Give it my Python code and have it run it for me. And once it's done, report about success, depending on predefined criteria. So when would I use one against the other? So I would normally use Lambda for short-running tasks, things that are very short, short-lived. And these things are very, very easy to build with Lambda, and there's a lot of examples the community uses. Long-running tasks is where you go into more complexity, because sometimes you need to use something called a continuation token. Again, for long-living tasks, when you need to receive feedback from the pipeline before you continue on to the next stage. But it's also something very manageable. Lambda supports a specific set of languages today, such as Node.js, Python, Java. And of course, it runs in AWS. And as I mentioned before, it's serverless. You don't need a server to run it. Give us your code, we take care of that for you, and you can orchestrate that run using the pipeline. Compared to a custom action, which can run any type of workload. Again, it's your job worker. You have it do whatever you'd like. It, of course, displays the status in the pipeline. It runs even on your premise. You can have it run on your premise or wherever you'd like, even on your desktop. And, of course, it does require compute resources as opposed to Lambda because you do need some sort of an instance, a compute instance that you can run your code on. But you can achieve the same results using both. Reaching towards the end. So what we've been through today, or what we shortly cover in this brief presentation, is how you can build and test your code in a continuous delivery pipeline. We also talked about a little bit about the differences between continuous integration and continuous deployment, which are similar processes, some of which include continuous delivery, and some of which are part of an early process, like continuous integration. If you apply this method of continuous delivery where you work, you would actually become faster without sacrificing your quality. Even more so, your quality would improve because now you have automated tests and quality assurance built into this process, into your pipeline. And of course, if you use some of our tools like CodePipeline, you will also be able to visualize, just like we do internally, your status of your pipeline. And whenever it breaks, you can pinpoint the problem significantly quicker than you would have had if you didn't have a software development pipeline. We have something called the starter kit, where you can get started with some live examples of very neat applications. I welcome you to try it out. And of course, we have some additional material about the entire DevOps process from our perspective and how we view continuous integration and continuous delivery. Thank you. Any questions?
Hey. Hello? Okay.
Hello.
You mentioned deploying to the code deploy tool.
Yes.
Is it compatible with container environments? Can you deploy containers? You mentioned that you can build containers with code.
Actually, we have, you can deploy containers using CodeDeploy, but we have a wide variety of tools that you could use to deploy containers, not just CodeDeploy. Are you familiar with our ACS service?
Not really.
So that's probably where you want to go when you work with containers. We have a dedicated service just for working with containers called ECS.
Okay, thanks.
Sure. Okay. Question?
Thank you very much for your talk, first of all. Secondly, the question is the following one. I saw that you were using S3 as Artifactor repository.
Yes.
Is it a best practice that you can suggest overall in a build pipeline, or it's just because of this, let's say, example that you showed us?
That's a great question.
Yeah.
Yes, that is a great question. Well, we try not to dictate the best practices for you. It's just one way you could use it. Some of our customers use, are you familiar with a tool called JFrog?
No, not with JFrog.
Okay, so there are a lot of tools to store your binaries, either your raw code or your, of course, your tested binaries. And we are super flexible. Right? You could use whatever tool you'd like. And what I've showed here is just one example on how you can do it. You can have this done via S3, and we can do it for you. Or, of course, you can use your own artifact store.
Yeah, no, that's the thing. Just to understand if it was Amazon best practice, because you know.
Yeah, it's just an example.
Yeah,
By
okay,
default,
cool.
if you don't give us one, we will use S3.
Yeah. Okay. Okay. Thank you very much. Thanks.
Sure. Anyone else? Last call? Okay. Thank you very much for your time. And it's good to be in Belgrade.